Hi there, I'm Lena, I'm a PhD in mathematics, and this is my book about mathematics around us. It happens sometimes that we need to measure, to calculate the area or volume of something that cannot be simply taken and measured. How to be in this case? Let's figure it out. Let's go.
Liftoff of the Delta rocket carrying blast.
So let's we need to calculate how many reindeer Santa Claus can keep. And for this, we need to calculate the area of Lapland. All we have is a map of Lapland and something very little like a ruler, for example, a stopwatch. We will calculate, obviously, with the help of ordinary magic. Let's first do a few magical passes. Let's take a stopwatch that counts time to the nearest thousandth of a second. Here, for example, such an online stopwatch. We will stop it at arbitrary moment of time and write down the last two digits, hundredths and thousandths of a second. Let's do this 200 times. While magic is always such an incomprehensible story, recurrent legends and the most stupid kind. After we get these 200 digits, let's take a square of 100 by 100 units and mark our fractions of a second on it. We will use one digit as a value on the abscess axis and the other as a value on the ordinate axis. So we get that 100 points are marked in a square 100 by 100 units. It's getting curiouser and curiouser, as Alice used to say. Now let's place our map into this square and calculate how many points are inside of the map and how many are not. It turns out that 37 points are inside the map and 63 respectively are outside. That is, it turns out that 37% of the points are inside the map. Now look, our map scale, 100 square kilometers, corresponds to 4 cells. That is, it turns out that our 100 by 100 square is, on the scale of the map, a square of 500 by 500 square kilometers. That is, the area of the square is 250,000 square kilometers. See, our points look like they've been pocketed into the map by accident. And the fact that 37% of them are inside the map of Lapland means purely intuitively that 37% of the territory of this square is the territory of Lapland. That is, it turned out 92,500 square kilometers. We go to Wikipedia, and what? The area of Lapland is 92,660 square kilometers. Mystic, isn't it? What was it? And why does it work? This is called the Monte Carlo method. In general, it was invented as a method for approximated multidimensional integrals, when we can't calculate it analytically and approximate by help with other methods. The mathematical idea of this method is very simple. The integral of any function on any set is nothing but the average of the function on this set. And we can approximate not the integral of a function, but the average of a function at this set. As we remember from school mathematics, the area under the curve is in general the integral of a function on a segment. So the method is also great for calculating the area. The main thing that we need for use the Monte Carlo method is to somehow generate a sequence of uniformly distributed random variables. A stopwatch with hundreds and thousands of a second works more or less well for this purpose, because they change too quickly to allow you to voluntarily or involuntarily hit too accurately. Although, if you press the button too rhythmically, you could distort the uniformity. In the same way, for example, a dice would fit. Or we could throw the needle on a paper lined with stripes and see if it crosses the strip or not. And yet, for example, using the Monte Carlo method, we can calculate the number p. To do this, we need to replace our map with a circle with radius is equal to 50. And we see how many of points are inside the circle. It turns out that 74. That is, the square of a circle is equal to 7,400 units. And we know that the square of a circle is equal to p multiplied by radius squared. And radius is equal to 50. Then, by simple calculations, we get that the number p is equal to 2.196. This is less like the real value of p than our area of Lapland looks like itself. Why is that? Because in general the accuracy of the Monte Carlo method is not very high. It has the order of 1 divided per root of n, where n is the number of our attempts. That is, if we take 1000 points, then our accuracy is 1 divided per root of 100. That is 1/10. To get an accuracy of 100, we need to take already 100 squared. That is 10,000 points. So for exact calculations, the method does not work very well. But if you are dealing with something that is difficult to calculate otherwise, it gives a quite tolerable result. Thanks for watching to the end. Like, subscribe, and write in the comments what else would be interesting to talk about.